So the general solution of transverse vibrations in the bar y equal to cos of omega t plus theta into a cos h of omega x by v plus b sin h of omega x by v plus c cos of omega x by v plus d sin omega x by v. This is, you say, equation 1. Okay. So now let us apply the first boundary condition at the first free end, x is equal to 0. So what is that? Now applying boundary condition at x is equal to 0, dou square y by dou x square equal to 0. So this is, you have to differentiate 2 times. First dou y by dou x, right? Again you differentiate second time, then you will get dou square y by dou x square equal to 0. What is that? Let us write dou y by dou x is equal to cos of omega t plus theta is constant. Cos h sin h hyperbolic functions. Cos h differentiation sin h sin comes sin h of omega x by v differentiation cos h. So for both positive sign. But whereas for cos theta minus sin theta and sin theta plus cos theta. But for hyperbolic functions, both for cos and sine, you get the positive sign. A cos, A constant, cos h differentiation sin h of omega x by v into d by dx of omega x by v, you will get omega by v plus b into sin h of omega x by v, differentiation of sine hyperbolic function cos h of omega x by v into d by dx of omega x by v, you will get omega by v plus c cos differentiation minus sine. So I am writing here minus c sine of omega x by v into d by dx of omega x by v, again omega by v, right, plus d by dx of this. For sine function, cos comes cos omega x by v into d by dx of omega x by v, again omega by v. In all 4 terms, in the brackets, in all 4 terms, we have omega by v. Hence, you can take that common. Cos of omega t plus theta into omega by v, a sin h of omega x by v, okay, plus b cos h of omega x by v minus c sin omega x by v plus d cos omega x by v. Right, sir? Now again, you differentiate once again with respect to x. Then left side, we get dou square y by dou x square, that equal to. So when we differentiate with respect to x in the above step, we are getting constant omega by v outside. Similarly, we will get another omega by v. Hence, I am writing here cos of omega t plus theta, it is constant. Omega by v into omega by v whole square. Okay. A sin differentiation cos comes cos h of omega x by v here plus b cos h of omega x by v differentiation sin h of omega x by v minus c sin differentiation cos of omega x by v here plus for cos omega x by v, will get minus sin minus d sin of omega x by v. This is equal to 0 because what the condition, boundary condition we have? Dou square y by dou x square equal to 0. So now we have written dou square y by dou x square. That expression, this one, sir. This is equal to 0. So it is not equals to 0, right? At x is equal to 0, dou square y by dou x square. You put x is equal to 0 in this. X is equal to 0, then this will be 0. Okay, that will be 0. This will be 0 because sine function. Here cos 0, 1. Here cos 0, 1. You will get a minus c equal to 0. Implies a is equal to c. So what is the boundary condition? At x is equal to 0, dou square y by dou x square equal to 0, 7. In this, you substitute x is equal to 0. This total cos h of 0 is 1. Okay, sin h of 0 is 0. Here cos 0, 1. D, sin 0, 0. So therefore, second term becomes 0. The last term becomes 0. Only the first and third term left. So here a minus c equal to 0, a equal to c. This is equation 2 or equation 3. Equation 2, sir. Right. Similarly, let us apply the second boundary condition. Dou cube y by dou x cube. Dou cube y by dou x cube. So again, I am writing dou square y by dou x square is equal to cos of omega t plus theta into omega by v whole square. That's it. Into a cos h of omega x by v plus b sin h of omega x by v minus c cos of omega x by v minus d sin of omega x by v. So this is this dou square y by dou x square, right? Now again, differentiate with respect to x. Then left side you will get dou cube y by dou x cube, dou cube y by dou x cube. So then what we get right side, cos of omega t plus theta. Here omega by v whole cube, right? A cos h differentiation sin h of omega x by v. Already omega by v taken common. Here plus b sin h omega x by v differentiation cos h of omega x by v minus c cos differentiation minus sin. So this becomes plus sin of omega x by v minus d sin differentiation cos omega x by v. So what is the second boundary condition? At the first end of the bar, at the first free end of the bar, at x is equal to 0, dou cube y by dou x cube equal to 0. Okay. So then you substitute in this x is equal to 0. X is equal to 0, this will be 0, right? So b into 0, this is 1, it is 1. This will be 0, this becomes 0. So it is 1, cos of omega x by v 1. Then b minus d equal to 0 implies b is equal to d. B equal to d. Let us substitute these two values in the general solution. So what is the general solution? Y is equal to this one, cos omega t plus theta into a cos omega h of omega x by v plus b sin h omega x by v plus c cos omega x by v. In this, a is equal to c. A equal to c. Here you substitute instead of c, a, and b equal to d we got. Instead of d, you substitute b. In the first term and third term, you will take common a. In the second term and fourth term, you can take the common b. Then I am writing the directly. So then that equation 1 becomes cos of omega t plus theta into a taking common cos h of omega x by v plus cos of omega x by v. Okay, x by v plus b into sin h of omega x by v plus sin of omega x by v. So this is cos of omega t plus theta total common factor. It is equation 4. So till now what we did, first we applied the boundary condition at the first free end. At x is equal to 0, dou square y by dou x square equal to 0. So general solution we differentiated with respect to x 2 times. Dou y by dou x and dou square y by dou x, that is equated to 0. From that a minus c equal to 0, we got a equal to c. And the second condition, dou cube y by dou x cube equal to 0. So from that we got b equal to d. This a equal to c and b equal to d value substituted in the first equation. Then y equal to cos of omega t plus theta into a taking common cos h of omega x by v plus sin h cos of omega x by v. Okay, plus b into sin h of omega x by v plus sin of omega x by v. Okay, sir. Now the next step is we have to apply the second boundary condition. The second free end. Second free end is what? At x is equal to L. Again, dou square y by dou x square equal to 0. Dou cube y by dou x cube equal to 0. Right. So then you will get here this one. So this is you differentiate dou square y by dou x square is what? A cos h of a cos h omega x by v plus b sin h omega x by v. Okay. In this, so this one. So from this, you will get a into cos h of omega L by v minus cos of omega L by v plus b into sin h of omega L by v minus sin of omega L by v equal to 0. ఏం లేదండి, ఇప్పుడు y is equal ఎక్స్ప్రెషన్ ఉంది కదా, సో దీన్ని డో y by డో ఎక్స్ చేయండి, మళ్ళీ డో స్క్వేర్ y by డో ఎక్స్ స్క్వేర్ చేయండి, చేసి x is equal L సబ్స్టిట్యూట్ చేస్తే మీకు ఈ స్టెప్ వస్తుంది. ఓకే, సో ఫ్రమ్ దిస్ a into cos h of omega L by v minus cos of omega L by v equal to, bring the second term right side, then minus b into sin h of omega L by v minus sin of omega L by v. This is equation 5. Similarly, the second boundary condition, dou q y by dou x cube equal to 0. Equation 4 ni 3 times differentiate here with respect to x. First dou y by dou x, dou square y by dou x square, dou cube y by dou x cube వస్తుంది కదా. ఇప్పుడు ఆల్రెడీ మనకి ఇక్కడ this is the dou square y by dou x square. దీన్నే మళ్ళా once again with respect to x differentiate చేసి అప్పుడు సబ్స్టిట్యూట్ చేస్తే అప్పుడు మీకు వస్తుంది a into sin h of omega L by v plus sin of omega L by v is equal to minus b into cos h of omega L by v minus cos of omega L by v. This is equation 6. Okay, ఈ గుర్తుపెట్టుకొని రాసిన ఏం లేదు. లేదంటే మీరు డీటెయిల్‌గా ఆ మిగిలిన రిమైనింగ్ స్టెప్స్ కూడా చేస్తే మరీ మంచిది. ఇప్పుడు ఏం చేద్దామంటే ఈక్వేషన్ 5ని ఈక్వేషన్ 6 తో డివైడ్ చేయండి. డివైడింగ్ ద ఈక్వేషన్ 5 విత్ ఈక్వేషన్ 6. సో వాట్ ఈస్ ఈక్వేషన్ 5 హియర్? దిస్ వన్ కదా. లెఫ్ట్ సైడ్ cos h of omega L by v minus cos omega L by v by sin h of omega L by v plus sin of omega L by v. సో ఇక్కడే రాస్తున్నాను. డివైడెడ్ బై a cancel, minus b cancel, right? Taking cross multiplication. So here the term, this denominator term are the same. A minus b into a minus b form. A minus b whole square. Cos h of omega L by v minus cos of omega L by v whole square. Okay. Whole square is equal to sin h of omega L by b plus this one. A plus b into a minus b form. A square minus b square form you will get. So what is that? Sin square h of omega L by v minus sin square omega L by v. This is equation 7. Equation 7. So this is a minus b whole square expand. A square plus b square minus 2ab form. So next step to I'm writing. Yes. So what is the next step? A minus b whole square form by expanding that. A square cos square h of omega L by v plus cos square omega L by v minus 2 cos h of omega L by v into cos of omega L by v. Right side. So right side, what is that? As it is you write sin square h of omega L by v minus sin square omega L by v. As it is rasa. ఈ sin square term ని left side రాయండి. Cos square h of omega L by v minus sin square h of omega L by v equal to okay. And also you bring this sin square term left side plus cos square omega L by v. Left side చేస్తే ప్లస్ అవుతుంది కదా. sin square omega L by v is equal to so this term అవతల అయిపోతే ప్లస్ అయ్యి 2 cos h of omega L by v cos of omega L by v. Cos square h of omega L by v minus hyperbolic cos square h theta minus sin square h theta. What is that? 1. ఇక్కడ ఇది 1 కదా. cos square theta plus sin square theta 1 అవుతుంది కదా. 2 plus 2 is equal to 2 cos h of omega L by v cos of omega L by v. So 1 equal to 1 into cos h of omega L by v cos of omega L by v. So finally ఏమొచ్చింది మనకు cos h of omega L by v cos of omega L by v equal to 1 వచ్చింది నాకు. ఈక్వేషన్ 8. సో దీన్ని మనము వేరే హైపర్బోలిక్ ఫంక్షన్స్ ప్రిన్సిపల్స్ ప్రకారంగా చేస్తే ఈ ఈక్వేషన్ నుంచి యూ కెన్ రైట్ tan of omega L by 2v is equal to plus or minus tan h of omega L by 2v వస్తుంది. ఇది మనం ఫార్ములా ప్రకారం డిరైవ్ చేసి వస్తుంది. ఇది డైరెక్ట్ తీసుకోండి, మీరు మళ్ళీ అదంతా డిరైవ్ చేయాల్సిన అవసరం లేదు. From expression 8 we can obtain this step. Tan of omega L by 2v equal to plus or minus tan h of omega L by 2v. ఇప్పుడు ఈ ఈక్వేషన్ సాల్వ్ చేయటం ఎట్లా? ఇప్పుడు ఇందులో మనకు రెండు ఫంక్షన్స్ ఉన్నాయి. tan theta ఫంక్షన్ ఉంది, దీని మొత్తం theta అనుకున్నాం. tan h of theta ఫంక్షన్ రైట్స్. ఈ ఈక్వేషన్ యొక్క సొల్యూషన్ ఎట్లా ఉంటుందంటే, మనం ఒకే tan h of omega l by 2v మీదనే ఈ రెండు గ్రాఫ్స్ ని డ్రా చేస్తే tan omega l by 2v గ్రాఫ్, tan h omega l by 2v గ్రాఫ్స్ రెండు ఇంటర్సెక్ట్ చేస్తాయి. ఆ రెండు గ్రాఫ్ల యొక్క కామన్ ఇంటర్సెక్టింగ్ పాయింట్స్ ఏవైతే ఉన్నాయో దట్ రిప్రజెంట్స్ వైబ్రేషనల్ మోడ్స్ ఆఫ్ ట్రాన్స్వర్స్ వైబ్రేషన్స్. tan omega l by 2v గ్రాఫ్, tan h omega l by 2v గ్రాఫ్ రెండు డ్రా చేస్తే ఒకే దాని మీద ఈ రెండింటి యొక్క కామన్ ఇంటర్సెక్టింగ్ పాయింట్స్, ఆ రెండు గ్రాఫ్స్ ఎక్కడైతే ఒకదాన్ని ఒకటి ఖండించుకుంటాయో, so that intersect points represents the vibrational possible modes of vibrations, transverse vibrations in the free bar. Okay, so what are the common points anante arunditi yokka at the plot of tan omega l by 2v and the plot of tan h of omega l by 2v ki cheste what you get is, that is omega l by v is equal to, it is not 2v sir, 2 omega l by va, omega l by v is equal to plus or minus tan h of omega l by v value how much ante what that values common intersecting points equal to pi by 4 into 3.012 5 7 9 and so on. Okay, now so graph మీద x axis మీద omega l by v తీసుకుంటాం. సో y axis మీద tan omega l by v గ్రాఫ్ తీసుకోండి, tan h of omega l by v గ్రాఫ్ తీసుకుంటే రెండింటి దీనికి సంబంధించిన గ్రాఫ్ వస్తుంది, దీనికి సంబంధించిన గ్రాఫ్ వస్తుంది. ఆ టూ గ్రాఫ్స్ ఎక్కడ ఒకదాన్ని ఒకటి ఇంటర్సెక్ట్ చేసుకుంటాయో ఆ ఇంటర్సెక్టింగ్ పాయింట్స్ వాల్యూస్ అంటే x omega l by v వాల్యూస్ x వాల్యూస్ 5 by 4 into 3.012 ఒకటి, 5 by 4 into 5 second point, 5 by 4 into 7 9 pi by 4, 11 pi by 4, 13 pi by 4. These are the intersecting points corresponding x values or omega l by v values. Okay, so first let us take the first value, omega l by v. Omega l by v, what is that omega l by v? Omega l by v equal to this one, where v is equal to, we have root of omega ck and c is equal to root of y by rho, the speed of longitudinal wave in the bar. So then the speed of transverse vibrations in the bar we equal under root omega ck, omega angular frequency, c this value k. Okay, c equal to y by rho. Now let us substitute these values. Omega value, what is that? What is omega? You substitute v is equal to top omega ck, sir. V is equal to under root omega ck. So from that f is equal to, finally will get pi ck by 8 l square, pi ck by 8 l square, 8 l square into 3.012 whole square, 3 square, 3 square, next 5 square, 7 square, 9 square and so on. In this omega equal to 2 pi f you substitute, omega equal to 2 pi f substitute. Okay, and v equal to root of omega ck you substitute, c equal to, so c as is there, omega 2 pi f into l by v. From that you write f as a subject, then pi f is equal to pi ck by 8 l square into these values. The first value pi ck by 8 l square into 3.012 whole square value represents fundamental mode of vibration. So we got the different values. F is equal to pi ck by 8 l square into 3.012 whole square, 3 square, 5 square, 7 square, 9 square and so on. In this first one, first value, what is that? pi ck by 8l square into 3.012 whole square. This is fundamental frequency. So frequency of fundamental mode of vibration, fundamental frequency. Second value, f2 equal to pi ck by 8l square into 3 square. This is called first overtone. First overtone of vibrating free bar. First overtone in the transverse vibration. Next, f3 equal to pi ck by 8l square into 5 square. This is known as second overtone. Second overtone. And f4 is equal pi ck by 8l square into 7 square. This is called as third overtone. Third overtone. So therefore, the frequencies of modes of vibrations possible in the free bar, transverse vibrations regarding fundamental frequency f1 equal to pi ck by 8l square into 3.012 whole square. First overtone f2 equal pi ck by 8l square into 3 square. Second overtone pi ck by 8l square into 5 square. Next, the third overtone 7 square and so on. Okay, so we can represent this. We can represent graphically the fundamental mode of vibration. This is f1, and the first overtone would be like this. The second overtone would be like this. This is f2 and f3. Okay, the graphical, the waveforms of the transverse vibrations in the free bar, fundamental modes of vibration. The waveform is like this. The first overtone waveform is like this. The third overtone, second overtone is like this. So this is about transverse vibrations. Transverse vibrations in a bar. What is that? Which at one end or both ends are free. Both ends are free. Okay. So in this class, we applied the boundary conditions at x is equal to 0, dou square y by dou x square equal to 0, dou q y by dou x cube equal to 0. And the same boundary condition applied at the second end also. Right, sir? So from that, for the first boundary condition, we got a equal to c, b equal to d, substituted that. After that, applying the secondary boundary condition at x is equal to L, dou square y by dou x square equal to 0, dou q y by dou x cube equal to 0. So finally, we got some expression. So the common intersecting point of tan of omega L by V and tan H of omega L by V, we got the values. So that values F is equal to pi ck by 8L square into 3.012 whole square, 3 square, 5 square, 7 square, and so on. Right? So where the first one, fundamental frequency, F2 first overtone, F3 second overtone, and so on. Okay.